Hello, beautiful people, and welcome. In this video, we're going to be talking about complex roots. So complex meaning complicated. They're not going to be pretty numbers. They're not going to be, some of them are not even going to be numbers. So let's go ahead and jump right into it. As always, disclaimer time. I am human. If I make a mistake, that's okay. Learn from my mistakes so that way you don't have to make your own. All right, two things we're going to start off with is the fundamental theorem of algebra and its corollary. Now, a corollary is just something that comes from an original statement. So it's a proposition that follows from one that's already been proved. So because this is true, this is also true. So every polynomial function, so this is the fundamental theorem of algebra, every polynomial function of degree greater than 1 has at least one zero, where a zero may be a complex number. The corollary, so because we know this is true, we also know the corollary is true, which is every polynomial function of degree n greater than 1 has exactly n zeros, including multiplicities. Now, two things are happening here. The first thing is multiplicities is a new word that we just introduced to you. Another thing is that we keep saying the degree of n greater than 1. What does that mean? That just means that when you have an polynomial, so let's say 6x cubed minus 2x plus 7, that means the highest exponent, and this is in expanded form, this is not in factored form, this is in expanded form, the highest exponent will tell you how many zeros you will actually have. So this polynomial will have 3 zeros. And the options are you can have 3 real zeros, you can have 3 complex zeros, you can have multiplicities. So again, multiplicities is a zero occurring more than once. So let's say we have a factored form polynomial. So let's say 3x times x minus 5 squared, x plus 8, I don't know, cubed, x minus 1 to the 5th power. So the total degree on a factored form is the highest exponent in the expanded form. So 5, 6, 7, 8, 9, 10, 11. So 11 is my total degree. That means I will have 11 zeros in this polynomial. And what does that mean with the 11 zeros in the polynomial? That would mean, sorry guys, I'm plugging my computer before it dies. And that would mean that in these 11 zeros, I'm going to have a zero. Again, zeros are x-intercepts. I have a 0 at 0. I have a 0 at 5. I have an x-intercept at -8. And I have an x-intercept at 1. The multiplicities that it's referring to is the exponents. That's our behavior at each zero. It behaves that way because of its multiplicity. So I will have a 0 at 0, 5. But here's the thing. 0 has an exponent of 1. 5 has an exponent of 2. So multiplicity, you'll see this mult. 2. I have a 0 at -8 with a multiplicity of 3. So again, the mult 3 is just the behavior. And I have an exponent at 1 with a multiplicity of 5. So I have 1 0 at 0. I have 5 as an I have 5 as an intercept with a multiplicity of 2. So that means I have 1. I have 2 here. I have 3 here. And I have 5 here, quantity of 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I should have 11 zeros total. And these are my actual zeros. So multiplicities just tells you how many you have in that particular, on that particular exponent. It's the behavior. So that is the fundamental theorem of algebra and the corollary. So fundamental theorem of algebra says you have an exponent of 1, you will have at least 1 0. The corollary says the highest degree in expanded form or your total degree in factored form, that is the quantity of zeros you're going to have. Now, these zeros could be real zeros, as in like integers. They could be rationals, like fractions, or they could be complex, like I. We're going to introduce I in this video. All right, now let's talk about the irrational root theorem. Irrational roots says if a polynomial equation has a root of a plus b square rooted of c, then the conjugate a minus b square rooted of c is also a root. This also relates to if you have an imaginary number like I. So if a plus bi is a root, so is a minus b. Now, what is a root? Again, root is a 0, an intercept. So an x-intercept at a plus bi, we're talking about graphing imaginary. So we're not actually going to be graphing this. We're not graphing complex root. We're just going to be graphing. In our previous unit, we graphed just the real integer zeros. These, you just need to know how to write polynomials. We're not graphing these polynomials anymore. We're writing them out. So then here, if you have, so how did we get this right here? You're going to end up having to use the quadratic formula. I know it's been a while. I will give you that formula in this video. You will put it in a thinking bubble because you will need it. So if you have one, you have the other. If you have one, you have the other. So if you have one, you must have the other. There is no way around it. If you have a complex root, if you have an imaginary root, if you have an irrational root, you have to have the conjugate. Now, what is a conjugate? A conjugate is you're going to change the sign in the middle of the two terms. So here's term 1. Here's the secondary term. You're going to change that sign. Here's one term. Here's the secondary term. You're going to change that sign. Here's 1, 2, 1, 2. You're going to change that sign. So the conjugate is changing the sign. All right, let's do an example of how this is going to apply to us. Trying to give you a good one. Let's do this one. Example, I have p of x is equal to x cubed minus 64. Now immediately I'm doing a happy dance because in order to find these roots, I can absolutely factor to find these roots. And so let's factor this. I have x cubed minus 4 cubed. So I have a bubble cubed minus a bubble cubed. So that means I have the difference of cubes. Oh, you guys can't see that. Let's zoom in a little bit. There you go. Difference of cubes. And so we have always same, always different, always positive. So always same. Again, that's on the sign. Always different. Always positive. Refer to your graphic organizer if you don't know where this came from. So what that means is I have a root or a 0 at 4. So I have an x-intercept at 4. What is my multiplicity? I'm looking outside of the bubble. My multiplicity is 1. Now, if we have a multiplicity of 1, if we have a behavior that's linear, we don't have to do anything. It's just 1. However, when I look at this is expanded form. This is our polynomial in the expanded form. I know that my highest degree is 3. That means I need a total of 3 zeros. That means I only have 1 0 here. 2 other zeros needs to come from this here. Now, if you are in my class, you should know that I told you that this is not factorable. Once we do a sum or a difference of cubes, then we're done. However, this is now factorable by you because we are going to find out the complex solution, complex zeros. So how do we do this? We know it's not factorable per our methods. So here you're going to use the quadratic formula. We want to know what x is. We want to know what that x-intercept is. So in a thinking bubble, in a right red thinking bubble. Quadratic formula is minus b plus or minus root b squared minus 4ac, and all of this is divided by 2a. Now, what is this BCA thingy? Let's talk about it. So I'm going to bring this out. I have x squared plus 4x plus 16. We're talking about the coefficients of these. So this is going to be your A, your B, your C. So A is equal to 1. Again, it's the coefficient. B is equal to positive 4. And C is equal to 16. So I'm going to take that and I'm going to plug it into my formula, which says negative b, so negative 4, plus or minus square root of 4 squared minus 4a is 1, c is 16. All of this is divided by 2a, which is 1. Calculator time. I have negative 4 plus or minus 16 minus 16. 4 times 16, that is 64. All divided by 2 times 1, which is just 2. So then I'm going to bring this out here just to save a little bit of space. I have negative 4 plus or minus square root of 16 minus 64. That's negative 48 divided by 2. Now, Miss Romadius, I can't. We can't. It's negative. That's okay. We're going to play around with some imaginary numbers. Okay, we're going to play with imaginary numbers. So, how do we even do this? We have negative 4 plus or minus the square root of negative 48. We're going to simplify that square root. I know that I'm going to have a negative 1 times 48. This here is the same thing as saying negative 4 plus or minus square root, change colors, of negative 1 times the square root of 48. All of that is still divided by 2. So negative 1 times negative 1 times 48 inside the root is the same thing as saying root 1 times root 48. So now we can continue and say negative 4 plus or minus root of negative 1. Here's another thinking bubble. Put it on this side. Square root of negative 1 is equal to I. So that means I squared is equal to negative 1. So make sure you know that not only do you need your quadratic formula, you need to know that I is equal to the square root of negative 1 and that I squared is equal to 1. All right, so then what do we have? We have negative 1. We still have this root 48. And we still are all dividing that by 2. So then what do we have? We're going to simplify this root 48 because I know that negative 4 plus or minus negative 1 times root 48. Root 48 is 16 times 3. Now you don't have to do this in as many steps as I did. Simplify it faster. I'm just wanting to show you all of my steps. And again, I'm going to do 4 squared, which is 16, times root 3. All of this is still divided by 2. So let's simplify negative 4 plus or minus negative 1 times 4 squared and square rooted is just 4. We still have our times root 3 divided by 2. And lastly, let's just simplify all of this. I have negative 4 plus or minus. This is negative 4 root 3 divided by 2. Oh, you guys, You guys. We had a -1. Do you see how this should be an I. This should be an I. I had a -1. I took the square root of it. That's equal to I. That's equal to I. Hopefully you saw that. Mistakes happen. Learn from my mistakes, you know, things like that. So that's I. And that's not a negative I. That's just I. Just I. Just a simple I. Hopefully you saw that. A square rooted -1 is equal to I. So when I have the square root of -1, that should simplify to just I. Sorry about that. All right, one last step. I'm going to split this up. I'm going to say -4 divided by 2 plus or minus 4I root 3 divided by 2. And lastly, we're going to simplify that. So I have as my final answer -2 plus or minus 2I root 3. Now this right here is in fact 2 roots. This is -2 plus 2I root 3, and the other one, -2 minus 2I root 3. That's where your irrational root theorem says you're going to have a plus, you're going to have a minus in between that root, that irrational root. So you have an I, just make sure that you see that you have an I. And these are your roots. So again, starting from the very beginning, how many zeros should we have? How many roots should we have? We should have 3 roots. We started out with one of them, which was 4. That was super duper easy. We loved that one. That one we had to use a quadratic formula to find out our 2 other zeros because we had only a multiplicity of 1. So I need 2 more zeros for a total of 3 zeros. All of that work later, we found out that we have -2 plus or minus 2I root 3 as my second and third zero. All right, let's do one more example, and then we're going to call it good for this video. Do an example of this. They're going to say, oh, I like this question. Write the polynomial given the following roots. Don't let roots confuse you. Roots are just zeros, which are our x-intercepts. So if we have x-intercepts and we want to write the polynomial, you're going to do exactly what you did with your graphing. I hesitated there for a second. I'm like, when did we do this? When we were not graphing, when we were writing the equation of a polynomial given a graph. So what we're going to do, here are the given. So example, you're going to have 2, 3, 1 plus I. Those are your zeros. Those are your x-intercepts. So what you're going to do is you're going to create that t-chart as you did before. So these are your roots or your x-intercept. You're going to do your opposite bubble. And you're going to check for multiplicities. Example for like behavior. So is your exponent 2? Is your exponent 1? What's your exponent? So what's my root? I have a root at 2, I had a root at 3, and I have a root at 1 plus I. Now, 1 plus I should give you all of the alerts. 1 plus I is a irrational complex root. So we need imaginary. I is imaginary. We're going to imagine I. So we need the conjugate of 1 minus I. Make sure that you have the conjugate. It will not tell you here. That is something you need to know. If you have one, you must have the other. The conjugate must be there. All right, now that we have this, we're going to do the opposite of that. Choose a different color. So I have, again, opposite bubble. We want x And we want something there. We want the opposite bubble. So if I have a 2, I'm going to write a -2. If I have a 3, I'm going to write a -3. If I have an I plus 1, you're going to change the symbols to all of it. This is what happens. You're going to do x minus 1 plus I. And then here you're going to do x minus 1 minus I. So do a minus, x minus. Do the opposite, x minus 2, x minus 3, x minus this, and x minus this. So what are the multiplicities? Unless they tell you like, hey, it's multiplicity 2, multiplicity 3, mult 5, the exponents are going to be 1. So this is 1, 1, 1, and 1. So when you're writing the polynomial, you're actually going to multiply these out because you want this in expanded form. So you're going to say I have an x minus 2 times x minus 3 times, you're going to distribute that negative inside just to make life a little easier. I have an x minus 1 minus I, and I have an x minus 1 plus I. Don't let this scare you. Don't worry about it. Don't let it scare you. What you're going to do is you're going to multiply this using box method. You're going to multiply these two using box method. So let's do that. X minus 2, x minus 3. If you wanted to use FOIL on this one, you can. X squared, this is negative 2x, this is negative 3x, this is positive 6. This one here is going to be a little bit more complicated. So x minus 1 minus I, x minus 1 plus I. I have an x squared, I have a minus x, I have a minus I x. Here I have a minus 1x, here I have a plus 1, and I have a minus, just kidding, a plus I. Here I have a plus xi. Here I have a minus I. And here I have a, what is this? Negative I squared. Now don't let these i's scare you. Again, let's do our thinking bubble. We said that I is equal to the root of -1, but we also said that I squared is equal to simply -1. So whenever you see -1, that equals to I squared, and whenever you see I squared, that equals to -1. So look at here, things are going to be wonderful. I have a minus ix, and I have a plus xi. Because these are the same thing and being multiplied, that's okay, we get to cross them out. They go away. Here is a plus I, here's a minus I. They go away. Here's my I squared, my negative I squared. Okay, negative I squared. Think about it this way. If I square both sides, that will give me -1. So if I have a negative I squared, that means I change the sign on this one. I'm going to change the sign on that one. That means I have a 1. Negative I squared is just a 1. So what do I have here? I have x squared. I have minus 2x. I have a plus 1. And I have another plus 1 right here. So plus 1, and then I have another plus 1. So I have a plus 2. I still have this one here that I need to multiply by. Oh, you guys can see that? That is x squared minus 5x plus 6. And I'm going to need to multiply that out one more time. So I'm going to change my paper since I'm running out of room. All right, so what do we have? One more time, I have x squared negative 5x 6. Forgot to draw my box before I did that. And so what do we have here? I have x squared minus 2x plus 2. And we're going to multiply. This is x to the 4th. This is minus 2x cubed. This is 2x squared. This is negative 5x cubed. This is positive 10x squared. And this is negative 10x. This one here is 6x squared minus 12x plus 12. And again, we're going to simplify things out. I have x to the 4th. I have, what do I have? 5, 6, 7 x cubed. I have 16, 17, 18 x squared, I have 22x, and I have positive 12. So all of this is we're writing the polynomial in expanded form given the zeros. So let's start. Quick review. What happened? The question is asking us to write a polynomial given the following roots. Roots are zeros, x-intercepts. They gave us 3 of them, but this one here is a hidden. It's like secret. Mathematicians are lazy. We didn't want to write the other one, so be careful. Anytime you see I or a square root, you know that the conjugate needs to happen. Conjugates are just different symbol in the middle. If it's a plus in the middle, you change it to a minus. If it's a minus, you change it to a plus. How are we finding out what our bubbles are? You're going to do exactly the same thing that you did when you were writing a polynomial from your graph. Here are your zeros. Make sure you have the conjugate as well. You're going to do the opposite bubble, meaning you're going to do x minus whatever you see. You're going to do the opposite. That being said, make sure that you are distributing that negative with your 1 plus I and 1 minus I. Multiplicities, they did not tell me I have multiplicity of anything, so that means my behaviors are 1. Here we're going to multiply. Once I have my opposite bubbles, I'm going to actually multiply. Multiply the 2 complex ones and multiply the 2 real ones together. Once you have this, you're going to then multiply those 2 together. Make sure that you are aware that I squared is -1, but a negative I squared is a positive 1. Root of -1, square root of -1 is equal to I. So when you multiply these, you're going to end up with this polynomial in expanded form given the zeros that they did in the beginning. All right, beautiful people, that is it for this video. I hope you enjoyed it. I will see you in my next one. Thank you so much for watching. Bye.